Imagine darkness surrounding you. You know it's daytime, but you see no light. You can hear the kids playing outside and you wish you could join them, but you can't. You can't go outside because you can't see. You are only 8 years old and already considered legally blind because you have a disease called Leber's congenital amaurosis, and it has been stealing your sight since the day you were born. You are about to undergo a revolutionary treatment that will insert a missing gene into your eye. You're scared, but you know it's the only chance you have to restore your vision. And 4 days after the surgery, you can't believe it. You can see better than ever before. You are Corey Haas, the boy who saved gene therapy. From the day I first learned about genetics, I have been fascinated by how genes work. And when I learned a little about gene therapy last year in AP Bio, I couldn't help but research and absorb everything I could about it. Gene therapy is important for all of us, especially now that it is being used to treat diseases such as cancer and heart disease that affect millions of Americans every year and could affect you or one of your loved ones. According to my questionnaire, many of you have not taken a college-level biology course or learned much about gene therapy. So today, I'm here to teach you about the role genes play in the body, how gene therapy can be used to alter or replace missing or defective genes, and finally tell you a little bit more about some of the diseases that gene therapy is being used to treat today. I'm going to start by talking about what genes are and the role they play in the body. Genes are composed of deoxyribonucleic acid, or DNA, and they are found on chromosomes that reside in the nucleus or control center of the cell. Dr. Eduardo Marvin, professor and chief of cardiology at Johns Hopkins University School of Medicine, defines a gene quite simply as a blueprint for inheritance and for the creation of all body parts. You may be wondering how a microscopic piece of DNA could possibly hold the potential to build an entire human body. And to discover that answer, we must take a journey inside the cell, based on information found in Biology, the 7th edition, a textbook by Campbell and Reese. It all starts in the nucleus, which is where the DNA is housed. Since the DNA is the blueprint for the body, it can't risk leaving the nucleus and getting damaged. Thus, it must be transcribed into a substance called messenger RNA, or mRNA for short. The mRNA is literally an exact copy of the DNA's genetic code, which will then set out to find the ribosome to translate it into a protein. At the ribosome, the mRNA is read, and transfer RNA molecules bring the amino acids that the gene codes for. The amino acids will then attach to one another to form large protein molecules that are used throughout the body. As you can see, the genetic code of DNA has the potential to build tons of different proteins. And the amazing thing about proteins is that they're the foundation for every single type of tissue in the body, from nervous to muscular to epithelial. And for this reason, if even one gene is missing or defective, the entire fate of the human body could be at stake. Luckily, the main topic of my speech today deals with a process that is working to lessen the severity of these genetic mishaps. So now that you know a little bit about genes and how they work, we can begin to discuss gene therapy and how it can be used to alter or replace missing or defective genes. According to Ricky Lewis, who has a doctorate in genetics and wrote the book The Forever Fix, Gene Therapy and the Boy Who Saved It, to whom I referred earlier, gene therapy is a biotechnology that corrects an abnormal gene by delivering a normal gene to the body part affected. As per my questionnaire results, many of you are only slightly familiar with the concept of gene therapy, and thus I will keep the explanation of the process simple. The first step in treating a patient with gene therapy is to isolate the gene that is the cause of the disease. This has been made a lot easier since the completion of the Human Genome Project in 2003, which mapped and identified every gene in the human genome. However, some diseases are caused by 2 or more genes, and thus, it's harder for doctors to pinpoint the exact genetic misprint in a patient's DNA. Once the defective gene is located, it's time to alter or replace it. Arthur Ninehus, a hematologist at St. Jude Children's Research Hospital in Memphis, Tennessee, says that researchers typically use viruses to carry genetic cargo into cells because that is what viruses evolved to do with their own genetic material. However, a virus is not the only way to carry genes into the body. In some cases, a sample of blood or bone marrow is taken from the patient, a new gene is injected into its immature cells, and forced to replicate as the cells divide. According to Nimes, once these cells are reintroduced into the body, they can travel throughout the bloodstream and multiply rapidly, eventually replacing the majority of defective cells. The final step of gene therapy is to wait and see. It may seem unfortunate, but gene therapy doesn't show immediate results because the cells that the new genes were introduced into need time to proliferate themselves and produce the protein that will heal the patient. Now that you know how gene therapy works, it's time to see some of the diseases that it can be used to treat. One of the first tests of gene therapy came in 1990, when Dr. William Anderson conducted a gene therapy trial on 2 young girls with SCID, severe combined immune deficiency, or bubble boy disease. Dr. Anderson traced the disorder down to the deficiency of a single enzyme, which is coded for by a gene. Unfortunately, this first stab at gene therapy could not be fully attributed to the changing of genes, because along with the new gene, both girls received injections of a synthetic enzyme, ADA, which was what they were missing. This stumble, however, only made researchers more intent on finding ways to use gene therapy in and of itself to cure SCID. Today, gene therapy is being used to treat all kinds of diseases, including one of the leading causes of death in the US, heart disease. Dr. Eduardo Marbin is exploring the possibility of using genes that promote blood vessel growth at the site of heart attack damage to promote healing. And furthermore, there is much progress in the way of using gene therapy as a personalized cancer treatment. Carl June of the University of Pennsylvania recently led a team of researchers to success as they treated 3 patients with chronic lymphocytic leukemia. Although this exact form of cancer is very rare, the methods used to treat it will be applicable to many different types of blood cancers that affect nearly 90,000 Americans every year. Also in laboratory and clinical trials are gene therapy treatments for certain types of blindness, such as the types Corey Haas had, and other inherited disorders such as Huntington's and Parkinson's disease. And while all of these things that I've spoken about thus far seem like successes, it's important to note in conclusion that gene therapy has had its rough spots. And so I feel obliged to address a question that may be on your mind from the beginning of this speech. Why was Corey Haas the boy who saved gene therapy? You see, tragedy struck this field in 1999 when 18-year-old Jesse Gelsinger died in a gene therapy experiment at the University of Pennsylvania. According to a New York Times article published on November 28, 1999, Jesse knew when he signed up for the trial that it wouldn't benefit him because it was designed to treat babies with a fatal form of his disorder called OTC. Believe it or not, he was reported to have told his friend the day before the surgery, "What's the worst that can happen? I die, and it's for the babies." So while many people, including Ricky Lewis, who coined the phrase, view Corey as the boy who saved gene therapy, I still think Jesse was a hero too. And after this horrible event, experimentation in the field came to a halt for about 2 years before doctors were allowed to test the waters again. And when Corey's treatment was a success, the field roared to life and hasn't stopped since. So I hope that my speech today has helped you to better understand the importance of genes in the body, the way gene therapy works, and some of the many diseases that gene therapy is being used to treat today.